We're going to continue on with our theme of trigonometric functions. We're going to look at some background, some significant digit information, solving triangles using our angles of elevation or depression, and some other more advanced applications. So a significant digit is a digit that's obtained by actual measurement. So what do we mean by digit? I mean how many points typically that are behind the decimal, but sometimes it's in front of the decimal. So how accurate do we need to be with our mathematical answer? Significant digits in the following examples are going to be identified with colors so we can look at this together. So in the number 408, I have three significant digits. 21.5, I have 3, 18.00, 6.700. Now notice the pattern here. So if I have a 0 value and a decimal, the zeros behind, none of the zeros count, only the actual ending values. And the same thing applies here. If I have zeros behind it, but in front of the decimal, the ones at the end do not count. Your answer should not be any more accurate than the least accurate number in your calculation. So in this problem, I have two significant digits because I have 62 degrees. So each value has two digits in it. So my answer cannot be more than two significant digits. This one, I have three significant digits because the 0 behind does not count. It would count if it was behind the decimal point, but because it's in front of the decimal point, it does not count. Then 60.4, the 0 does count because it's between two values, so that would be 3. Here I have 48, 81, 48, four significant digits, and then I have 5 because I'm going to have 4 here plus 1 here. So 10, 52, and then the 2 count. The 0 behind it is not behind the decimal point, so it does not count. And then here I have 5 significant digits. So when we're working in the lab and you're not sure where to round your answer to, this is basically the rounding rule process for how many values you should be showing for accuracy. To solve a triangle, it means to get all the measures of all the angles, so all three angles, and the measure of the three sides. When solving a triangle, it's really important to sketch it out. You're going to use a lot of scratch paper in this section, as well as really in the whole class. When we're representing sides, we use lowercase letters. That's just a mathematical notation convention. When we're doing angles, we capitalize the letters. So just the naming convention. You should notice that side A is opposite angle A. Side B is opposite angle B. This is just a traditional naming convention that we all follow to make sure our work is on the same page and makes sense. In a right triangle, we only use the letter C for the hypotenuse. So I would never want to call this a different letter because it has to be opposite the right angle. That's always going to be your C value. If I wanted to solve a right triangle, given this angle and this length, we have to keep in mind we orient ourselves with the angle. So that I'm located here. They gave me the hypotenuse, and I need to solve for the opposite and the adjacent. Well, I can only solve for one thing at a time. So let's say I want to solve for the opposite first. So if I want to solve for the opposite, I know the hypotenuse. That's going to be my sine function. I'm going to have the sine of my angle equals my opposite leg over my hypotenuse. I'm going to multiply both sides by the hypotenuse to get my final answer. Notice there are three significant digits because I have 1, 2, 3, 1, 2, 3. Then if I want to solve for my adjacent leg, that would be the leg touching A. So I would get the cosine of angle A equals my adjacent over my hypotenuse. I'm going to complete that multiplication out to get 10.5. Now to find the third angle, I can just take the 90 and subtract the value of A to get 55 degrees and 30 minutes. So now I have all three sides all three angles. We could have found the measure of angle B first. It doesn't matter the order that you go in to solve, as long as you find all three angles, all three sides. It can also be solved several ways. So sometimes you might want to find one with a trig function and then do the Pythagorean theorem. That's fine to do. Sometimes it's a little trickier with the significant digits when you're doing that method, but it is possible. For accuracy, we want to use what is given to us as much as possible. So that way, if I make a mistake and say step 3, that mistake isn't carried through with every following step. So it's always best to use what we're given, just to make sure we're as accurate as possible. If I want to solve this triangle, I'm given two sides. So the quickest thing to do here would be to solve for the third side using the Pythagorean theorem, but we're going to go ahead and find that sine first. So sine is my opposite over my hypotenuse. So if I'm located at A, opposite hypotenuse, and then I'm going to hit second on the Web 2.0 calculator, sine, and it's going to give me 33.32. I need 4 significant digits, because this is 4. Then I can say, well, this angle is 90. So really what I'm doing here when I'm saying 90 minus this is I'm saying 180 minus 90 minus this gives me my third angle. Now I can do the Pythagorean theorem to get that nice decimal value to 4 significant digits. So you're going to be basically going between the Pythagorean theorem and SOHCAHTOA to get these answers right. An angle of elevation, this is how I think about it, is looking up. So if you're looking up in the sky, you're looking at an angle of elevation because your natural eye line is going to be on the horizon. But if you tilt your chin up, the angle from your chin to the natural resting place of your face when you're at rest, that's an angle of elevation. If it's depression, you're looking down. And so that's the angle from your natural chin location to where you've tilted your head down. You've got to really watch these angles of depression because they're both measured between the line of sight and a horizontal line. But in depression, you're looking down. Elevation, you're looking up. So to solve a trig problem, there are a few steps we're going to follow. You have to draw a sketch and label it. If you're trying to do this course without using scratch paper, you're not going to be successful. You have to draw. I draw terribly, and I still draw sketches and still manage to get answers right. Don't have to be Picasso, but it's going to be really helpful to draw it out. Once we have the sketch, we're going to use that to write an equation that relates everything together and wraps it up. We're going to solve that equation to see if it makes sense. So in this question, I have a point A, 123 feet from the base of the flagpole. The angle of elevation is looking up. So see how this is looking up? If I was standing here at A, my chin would be up. And my angle of elevation is 26 and 40 degrees. Find the height. So I'm located at A. This is my opposite I'm going to find. This is my adjacent that I know. So I'm going to use tangent. So I'm going to do tangent of that angle is my opposite over my adjacent, and I'm going to multiply both sides by 123. How did I know to round to 0.8? Well, because I have 1, 2, 3 significant digits. Here, if I'm standing at point A and I'm looking down at the lighthouse, that is an angle of depression. So notice the angle of depression is outside of my triangle. I have this triangle, this triangle here is given by these legs, but that angle is out here, it's not in here. So this actual angle is going to be found by doing 90 minus this angle right here. So to get the angle within my triangle, this forms a perpendicular, and I'm going to have to take this value and minus it to find that. If I want to find the angle of depression from the top of the cliff to here, that would be this angle right here. But to find that angle, I've kind of got to find what's going on over here. Now here's an interesting thing. These are two parallel lines, which means that this angle is congruent to angle B. So that's why we're actually talking about angle B when it's inside the triangle and not angle A, because this is going to be alternate interior angles. So I can find angle B by knowing, and then if I know angle B, I know this. So let's look at this. We're going to do tangent of B would be opposite over adjacent. How do I know? Because I have to use what I'm given. If I don't know what B is, I have to use the two things I do know to find it. So I'm going to go to second tangent. I'm going to type in my quotient, and I get 26 degrees. Technically, that's this angle right here. But by alternate interior angles, it's also this angle right here. Now, a lot of students will say negative 26 degrees. Because we're putting the words angle of depression behind it, we don't need to make it negative. Now, for a bearing, we have two main methods for expressing bearing. What is bearing? Bearing is giving directions. So when I give a single angle, it's implying that I'm measuring that specific angle in a clockwise direction from due north. So these are all bearings. They all are measured from north. So remember how we used to use the origin and the coordinate plane to move around. With angles and bearings, we use the vertical axis as kind of our origin point. Now, to solve a problem with a bearing, you're going to have to sketch it out. It's so important to draw these sketches. Look at this sketch. This is a ton of stuff happening. Again, alternate interior angles. Help me with this. Then I can find this is a 90-degree angle. So 90 minus 61 gives me this 29 value. Alternate interior is what gives me this value. So I have a lot of right angles being formed here, and I have some things that are complementary. If I want to find cosine of 29, that's going to be my adjacent over my hypotenuse. I'm going to multiply both sides by 3.7, and I'm going to get 3.2. It is very, very critical that you sketch the drawing so that you can draw your angles correctly. The other method for measuring a bearing is slightly different. It goes from the north-south. I don't advise doing this. I advise doing it the traditional way. So here is my sketch from this with the ship leaving port. I have a right angle because of how I'm using those bearings to maneuver my ship. So I draw my sketch, then I can use the information in my sketch to find those missing angles. Once I have the sketch, I need something that's going to relate my distance, my rate, and time to find the distance from A to B. Now notice A to B is a hypotenuse, so that'll be important later. Where did 88 come from? Well, I know my speed, I know the time I'm traveling, so I can solve for these two sides. So to find the third side, I can just plug it into the Pythagorean theorem. So 90% of this question was drawing the sketch. If you don't draw the sketch, you can't get these questions right. It's very important to draw the sketch. Now, the subtend spar method is a side note that we don't really cover in this class, so I'm going to go ahead and skip through this slide for the explanation of this. Now, here's another example of the angle of elevation that I wanted to tackle with this image they're giving me here. Do you see that I have two different triangles here? I have this triangle right here, and then I have this triangle right here. I have multiple things that I don't know here. I don't know my x value. I don't know my h value, but I do know some of these angles here. Since nothing is given to me about the hypotenuse of either triangle, I need to use a ratio that doesn't use the hypotenuse, which would be good to use tangent because I know this 50, I know this angle. So since I know these two things, I could find this. So that's exactly what I'm going to do. I'm going to try and find the information that's missing. So if I have the tangent of 36.7, that would be h over x. And then I can work from there. I would probably suggest finding your trig function to find the hypotenuse, then using the hypotenuse to find your opposite and adjacent. I wouldn't actually do it in the manner this slide does it. Now, we're not going to do the graphing calculator solution simply because we're using the Web 2.0 calculator, so it does look a little bit different than this. And that concludes this section.